modules. Let's move on to the next module of this chapter. Again, a module based on AN and SN formula. The sum is given A is equal to 2, D is equal to 8, SN is equal to 90, find N and AN. So what is given to us? For the given AP, A is equal to 2, D is equal to 8, SN is equal to 90. Because SN is given to us, we need to use SN formula. So let's do it. We know that Sn is equal to which formula? The first formula, because D is given, right? N upon 2 into 2a plus n minus 1 into D. Let's substitute the values and find the value of n. What are the values that we need to substitute? Sn is 90. What are the other values that we need to substitute? A as 2 and D as 8. So let's do it. You get n upon 2. N is something which we need to find out. You get 2 into 2 plus n minus 1 into 8. Right? Let's do the calculations now. 2 goes to the numerator. You get 90 into 2 is equal to n into 4 plus, open the brackets, you get 8 into n, that is 8n. 8 into minus 1, that's minus 8. Right? Let's move it further. 90 into 2 will give you 180. N, 4 minus 8 is minus 4. So you get 8n minus 4. Right? Open the brackets again. What we get? 180 is equal to n into 8n is 8n square. N into minus 4 is minus 4n. Again, we are getting a quadratic equations. So bring all the terms on one side so that there is a 0 on the other side. Let's do it. You get 180 to the other side. You get 0 is equal to 8n square minus 4n minus 180. Now write it in the standard form. You get 8n square minus 4n minus 180 is equal to 0. Hold on. 8, 4, 180. Can we simplify this further? Yes. How? Dividing throughout by 4. Right? Let's divide throughout by 4. What do we get? We get 2n square minus n minus 20 minus 45 is equal to 0. Right? Now we get a quadratic equation in its simple form. Let's now solve it by the method of factorization. How do we do it? We need to find the factors of 2 into 45, that's 90, which on subtraction gives us minus 1. Why on subtraction? Because the last term's sign is negative. Right? So let's find the factors of 2 and 45. The factor of 2 is 2. And 45 is, as we all know, it is 3 into 3 into 5, right? Let's find the factors in such a way that on subtraction, it gives you minus 1. As per the rule, you remember I told you, take the biggest number first, that's 5, and other numbers. The other numbers are 2 into 3 into 3. So 2 3s are 6, 6 3s are 18. So the two factors are 5 and 18. But will 5 and 18 on subtraction give us 1? No, it will not. Then what is the other option? The other option is 5, that is the biggest number, along with the smallest number, that is 2. So 5 into 2 is 10 as one of the factors, and 3 into 3 is 9 as the other factor. Now will 10 and 9 on subtraction give us 1? Yes, it will. Right? So the two factors are 10 and 9, but because the middle sign is negative, the bigger factor will be negative and the smaller factor will be positive. So it's minus 10 plus 9, the factors. Let's factorize it now. What do we get? 2n square minus 10n plus 9n minus 45 is equal to 0. Let's take common from the first two terms. You get 2n common, bracket n minus 5. Let's take common from the next two terms. 9 is common, n minus 5 is equal to 0. n minus 5 into 2n plus 9 is equal to 0. Therefore, n minus 5 is 0 or 2n plus 9 is 0. Therefore, n is equal to 5 or n is equal to minus 9 upon 2. But then, as we all know, n cannot be negative because n is nothing but the number of terms. And because n cannot be negative, n is equal to 5. Is the sum over? No. We are supposed to find an also. To find an, we need to use the formula for an. An is equal to a plus n minus 1 into d. We know a is 2, d is 8 and n is 5. So let's substitute. We get 2 plus 5 minus 1 into 8. You get 2 plus 4 into 8. That's 2 plus 32, which is equal to 34. So an or a phi is equal to 32. Therefore, n is equal to phi and an is equal to 34. As simple as that.